Hello, good evening. So, today we are going to discuss a very basic concept, right? A very basic uh, reason why the OSPF is a link state protocol, right? So, everyone saying that OSPF is a link state protocol. So, why do we call as OSPF as a link state protocol? Okay. So, OSPF is a link state protocol. Suppose if there is a change in the network, whether it's an addition or removal. Suppose this is an area 0, we have a three routers r1, r2, r3. Some every router have some of the networks running behind them. Suppose we have added a new network behind the r1, right? That's a 192.168.1.0/24. So if there is any change of the network, so here is a change in the network. So once there is a change in the network, then r1 will send an update to all of the routers in the OSPF domain, especially within the same area. So it was sent to the R2, it was sent to the R3. Once they will get this LSA update in the forms of the LSA, so change in the network. So routers will send the update in the form of the LSA. Okay. Once they will receive the LSA, they will update their database. Okay, once they will update the database, then they will, so database is just like they have a map, right? They will create their own database independently. It's like they have created their own map independently, each and every routers in the domain. And after, and with the help of that database, they will calculate the cost or a metric, best metric to reach the new network, right? So everyone will do this independently. So whenever there is a change, so every router will do this independently. So where this change has been made, that originator router will be uh, send the LSA and send the update in the form of the LSA, and the router will update their database. Okay, that database updating the database meaning that they will update their a map, so they will have a complete map of a network, and with the help of, with the analyzing that map, they will calculate the cost. So this is why this is called the link state protocol. So OSPF is known as a link state protocol for this reason. Okay, so what exactly is a link state is information of the link, or information of the interfaces. What our IP address has been configured, what is the subnet has been configured, right? What are the, under which subnet it falls. Okay, so this is what the is a link state, right? How many interface? Suppose R1 have how many interfaces over there, which is under the OSPF. That is over the link state. Okay, so once in this case they will send an LSA, but with this LSA, how do they? First thing is LSA will be flooded to every router, right? So get a copy. So, but how do this the loop prevention will be happen? Suppose R1 generate an LSA to right to R2. So the two main information would be the originator who is in originating it, that's an R1, and there is a sequence number increment. So there is a sequence number concept. When there is a new update, then R1 will be send this with the sequence number 0x80002, and the same information will go to R3, right, in the board direction. Once R2 will receive it, it will send to R3, right? And once R3 will receive this LSA, this will send to the R2. But don't you think this will create a kind of a infinite loop, right? We have to deny, or we have to stop this loop. So how we can stop this loop or deny this circle, vicious circle? So whenever this LSA will generate, that's an update, it will go to the R2. R2 will we check, do we have an updated sequence number at 0x8002 in my database, right? It if yes or no. In this case it will not have, because the first time it is receiving, and it will check the who's the originator, then it's an R1, it will take the copy of it. The same it will goes to the R3. R will, so the sequence number, it will check the existing sequence numbers. Existing sequence number should be less than the this sequence number. which is under the LSA. So R1 0x8002 before was existing could be 0x8001. So it will accept this R sequence number as well as originator ID as an LSA update. Okay, R2 it will R1 to R3, suppose it takes 1 second. From R1 to R3 it will uh, R1 to R3 with the direct connection it takes a 1 second. From the R1 to R3 via R2 it will second a 5 seconds or 3 seconds. Then in that case R2 will, once R2 will send this LSA I have just highlighted in a red. Okay, it will also reach to the R3. R3 will check uh, what is the sequence number 0x8002. Okay, so I already have this sequence number. I have updated my sequence number with 0x8002. Then again it will check who is originator. Then it will check, okay, originator is also R1. Then it will do a kind of a checksum, right? Then it will find both of them have the same output as a checksum, right? So what it will do, it will discard this LSA which he got from the R2, and it will keep this LSA which is he get from the R1, because it was reach before, right? The black LSA reached to the R3 faster than the red LSA, so it will discard this one, and it will, so it will stop the vicious circle in this direction. Okay, now so R3 will discard it LSA receive as it already have updated the sequence number. The same way R3 will send an LSA what he has received from the R1. Once it reach to the R1, R2, it will check the sequence number. Number is the same with the existing one, because few seconds back it is already updated its sequence number, and it will check the originator, who is originator. Then it will check originator is R1 only. Then it will do some checksum calculation. In this checksum calculation, both of they have the same value. Then it can easily detect that it is a duplicate LSA, right? So it will discard the red one which he received from the R2, sorry, R3. So in this case also it will stop this vicious circle. So this is how the LSA works, and this is how we stop the vicious circle or the loop. You will not find this uh, you will find this concept in a book, but you will not find this concept designed like this, or try to make it like in a triangular form, or how things, or try to break into the simpler form. So I just try to make the things in a simpler form, so anyone can easily understand, and it will not, because mostly in the books they are making it a complex, but this is how the basic functions works, right? And this is how they will stop it. Okay, thank you.